Hello and welcome to my channel, and in today's tutorial we are going to look at 9709 paper 5-2 May June 2023. This is a stat paper, probability and statistics 1. Alright, if you haven't subscribed to my channel, make sure that you click on the subscribe button and let's begin. So in today's tutorial I'll be sharing with you some helpful tips so that you do not miss out on that A on your stats exam, right? So question number 1, the random variable x takes the values -2, 2 and 3, and it's given to you that the probability x equal to x is k times x squared minus 1, where k is a constant. Draw up a probability distribution table as numerical fractions. Important to remember that it has to be numerical fractions. So now we know that x can take the values -2, 2 and 3. So let's say if x is equal to -2, probability of x equal to -2, that's going to be k times -2 square minus 1. So it's going to be 4 minus 1, which is 3k. Probability as x equal to 2 is going to be the same thing, 2 square minus 1, 4 minus 1, which is 3k. And probability as x equal to 3 is going to be k bracket 3 square minus 1, which is 9 minus 1, 8k. Got to remember that all these probabilities, they add up to 1. So that means 3k plus 3k plus 8k is equal to 1. Therefore, 6 plus 8, that's 14k, equal to 1. K is 1 over 14. And then you can draw your distribution table with -2, 2 and 3. And the probabilities are 3k, so it's going to be 3 over 14, 3 over 14, and 8 over 14. That's about part A. Part B, find Ex and variance of x. So Ex is going to be sum of x times the probability. So we're just going to multiply -2 times 3 over 14. Let's put that in bracket. 2 times 3 over 14 plus 3 times 8 over 14. That's your Ex. Okay, let us calculate that. What do we get? We just say that this is -6 plus 6, 24 over 14. So that's basically 24 over 14, which is equal to 12 over 7. Right? Now, the variance of x is going to be Ex square times probability minus the mean square, the one which you calculated just now. So you square the x value and multiply it by probability. So the square of -2 times the probability, then 2 square times the probability plus 3 square times the probability minus 12 over 7 bracket square. So that gives me 4 times 3, which is 12, plus 12 plus 9 times 8, which is 72 over 14 minus 12 over 7 bracket square. Let us evaluate that. That gives me 3.92. Remember, your answers have to be correct to 3 significant figures. Otherwise, you're going to lose marks at every question. Yeah. Well, with Ex and Varx, you can leave it as fraction, but the rest of it has to be 3 significant figures, right? Let's move on to next question. A sports event is taking place for 4 days beginning on Sunday. The probability that it will rain on Sunday is 0.4. On any subsequent day, the probability it will rain is 0.7 if it rained on the previous day and 0.2 if it did not rain on the previous day. Find the probability that it does not rain on any of the 4 days of the event. So it doesn't rain at all. So we need to calculate probability of no rain. Right. So on the first day, what is the probability that it doesn't rain? So it starts on Sunday. Sunday, the probability it rains is 0.4. So obviously, no raining, it would be 0.6 times. On any subsequent day, it will rain is 0.7 if it rained on the previous day, and 0.2 if it rained on the previous day. So you got to understand that it is 0.2. The probability of raining is 0.2 if it didn't rain on the previous day. So if now here it didn't rain on the previous day, so the probability of not raining would be 0.8. And that is true for, this is Sunday, it will be true for Monday, Tuesday, and Wednesday. So could I then just write it as 0.8 times 0.8 times 0.8? So this works out to be 0.3072. You can leave it as a fraction. Here, you do not round because it's asking for the probability, so it has to be exact value. Yeah, so you could write it as 192 over 625. That is also acceptable. Yeah, find the probability that the first day on which it rains during the event is Tuesday. So we begin the event on Sunday, then we have Monday and Tuesday. We know that it should rain on Tuesday. It means that it doesn't rain on the previous 2 days. So raining on Tuesday will be, doesn't rain on Sunday, so 0.6. It rains on Monday. It doesn't rain on Monday, so 0.8. And then it should rain on Tuesday. So raining, the probability of raining, if it didn't rain on the previous day, is 0.2. Yeah, you can see over here. So this works out to be 0.096. All right. Part C, find the probability that it rains on exactly one of the days in the event. So we have 4 days, Sunday, Monday, Tuesday, and Wednesday. It should rain on exactly one day of the event. So let's say it rains on Sunday, then it cannot rain on the other days, right? So no rain on the other days. So what would be the probability? The probability of raining on a Sunday would be 0.4. Yeah, 0.4. And because it rained on the previous day, if it rains on the previous day, the next day, the probability that it will rain is 0.3. So does not rain would be 0.3. And then it didn't rain, so the next 2 days will have a probability of 0.8, 0.8. So for you to understand this better, you may want to draw probably, if you're getting confused, you may want to draw a tree diagram, something like this. On Sunday, we know that it's the first day, the probability of raining is 0.4. The probability of not raining is 0.6. Then on the subsequent day, this is the subsequent day, it will rain would be 0.7, doesn't rain would be 0.3. And here it would be raining 0.2 and not raining 0.8. So I guess this would make your thinking a bit faster. So let's say it rains on Monday. That means the other days it doesn't rain. The first day it doesn't rain, so it's going to be 0.6, as you can see in my tree diagram as well. And then because it didn't rain, the next day it's raining, so it's going to be 0.2 times, now it rained on Monday. Yeah, so we are looking at, if it rained what is the next day it doesn't rain? It's going to be 0.3. And it didn't rain on the previous day, so we are here again, and we look at it doesn't rain on the next day again, which would be 0.8. So you have to constantly see the previous day whether it rained or it didn't rain, and then you move back. If it didn't rain, you move back here. If it rained, you move back here, and then you decide if it's raining or not raining. All right, then let's look at the next one. Doesn't rain on Sunday, doesn't rain on Monday, it rains on Tuesday, and doesn't rain on Wednesday. So that's first day it's not raining, so clearly first day not raining is going to be 0.6. Next day not raining, so the previous day also didn't rain, so again 0.8. Now it's going to rain, so previous day it didn't rain, now it's going to rain, so 0.2 times, it will be next one would be 0.3 because it rained on the previous day. It rained here, so go back to the raining, and now it's not raining, so 0.3. Yeah, the last one would be then doesn't rain Sunday, Monday, Tuesday, and Wednesday it's going to rain, so 0.6, 0.8, 0.8, and the last day it's going to rain, so 0.2. Now, if you work out each of these calculations, it's going to give you 0.0768, 0.0288. This is the same. As you can see, the numbers are pretty much the same. 288, 0768. All right. So the total would be, you add them up, that gives you 0.2112. Yeah, probabilities, it's a good idea to leave them as a fraction. Yeah, because if you're not sure about rounding, probabilities you can leave them as fraction in simplest form, or unsimplified is also acceptable. Yeah. All right, let's move on to question number 3. The following back-to-back stem and leaf diagram represents monthly salaries in dollars of 27 employees at each of the two companies A and B. So we have two companies A and B. Now we need to find the median interquartile range and of the monthly salaries of company A. Now you need to read the key. Here the key indicates that 1 to 7 means 2,710. Got to remember, it's not 271, it is 2,710. So that's an important information. Yeah. Now let's calculate the median of company A. So the median, as we would normally do, we know that there are 27 employees. So median is the middle number. So you do n plus 1 divide by 2. So you do 27 plus 1 divide by 2. That is the 14th value. So you need to identify what is the 14th value. Yeah. So median is the 14th value. So you start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the median is going to be then 2,710. That's going to be your median. Now the median divides the data into two equal halves. Now the interquartile range is Q3 minus Q1. So Q1 is the median of lower half. Okay, median of lower half. So let's try to find the median of lower half. So how many are left? So if this was the 14th value, that means we are left with 13 values there. So it's going to be 13 plus 1 divide by 2. 13 plus 1 is 14, divide by 2 is the 7th value. So Q1 is going to be the 7th value before the median. 1, 2, 3, 4, 5, 6, 7. So it's going to be this value over here. So it's 2,610. And Q3 is going to be the 7th value after the median. 1, 2, 3, 4, 5, 6, 7. So it's going to be this value, which is 2840. So IQR is then going to be Q3 minus Q1, which is 2840 minus 2610, which works out to 2030. All right. So the next part is asking you to draw box and whisker plots. They also gave you information about the interquartile range, median, and upper quartile of the company B. So we calculated for company A. Now we need to draw box and whisker plots for both companies A and B. So let me just copy down what we have for company A. For company A, we need the lower quartile and the least value. So for company A, what is the least value? Is the first value here, 2500. Let me just list it down. That's the least value. Then we need Q1, which we calculated, 2610. Then we need the median, that is 2710. We need the Q3, which is 2840. And we need the highest value, which is the last value in this thing. So it is 3010. 3010. Right? So company B, what is the least value? The least value for company B is 2570. Sorry, 2540. Q1 is given to you here. That's the Q1. That's the median. That is the Q3. And the greatest value is the last value. That is 3090. So now to draw this, if you look at the values, you have the least value is 2500 and the greatest value is 3090. So you need to choose a scale which will fit all of them. Yeah. So I am going to start with 2500. Let's say that is 2500, 2600, 2700, 2800, 2900, 3000, 3100. All right. So that is monthly salary in dollars. Remember, you need to label your diagram, otherwise you're going to lose 1 mark. And on this side, we are going to have the companies, which is A and B. So company A and company B. So let's put company A here and company B at the bottom maybe. So the first value we have over here is 2500 for company A. So let's mark that. It doesn't matter how big is the length over here, but you got to be consistent. So 2610, 2710, next is 2840, yeah, and 3010. So that's going to be over here. So let's connect that. So I draw the whiskers. Now for company B, the least value is 2540. So that's going to be here. Then we have 2600, 2690, 2780, and the greatest value is 3090. It's going to be over here. connect the box and draw the whiskers. Okay, so that's the answer for part B. Part C is asking you to comment on whether the mean would be more appropriate measure than the median for comparing the given information for the two companies. So we've got to think about, is mean affected by any extreme values? Are there any extreme values? Yeah, and based on that comparison, if you see if there is any extreme value, then of course the mean will be affected. I can see that this is a very extreme value. If you look at the values in company B, they're all saturated within 2500 to 2800 maybe, and this value is an extreme value, yeah, because it's way too far away from the rest of the values. So we would say that mean is affected by the extreme value for company B. We need to mention the value, that is $3,090. So you would say that median is more appropriate. So median is more appropriate measure. Measure than mean. Right? So that should give you full marks because you listed Y, because of the extreme value. You also listed the extreme value. You got to list the extreme value. It's important. If you don't make reference, then you will not get the marks. Yeah. So before moving on to question number 4, if you haven't subscribed to my channel, please do so because it motivates me, and I will be creating more videos of this kind for your help. So question 4. A fair 5-sided spinner has label 1, 2, 3, 4 and 5. The spinner is spun repeatedly. So if you see the word repeatedly, clearly you know that this is a geometric distribution. So this is a geometric distribution, and we know that because of the word repeatedly. It is spun repeatedly until 2 is obtained on the side of on which the spinner lands. The random variable x denotes the number of spins required. So probability of x equal to 4. So probability of x equal to 4. So that means that the spinner lands on 4. So probability of x equal to 4, we're going to use the formula for geometric distribution. It is going to be equal to, we know that there is only one 4, yeah. So if I have to define the geometric distribution, the probability of obtaining any one of them is 1 out of 5, right? So in geometric, you first have the failures. 1 out of 5 is nothing but 0.2. So we could write this as 0.2. So you have failures for the first 3 attempts, and then the 4th attempt you have a success. That is the meaning of geometric. So you fail, and then at the end you get success. So probability of failing would be 0.3, and probability of success is 0.4. So that is on the 4th attempt. So the first 3 attempts are going to be failing, and the 4th attempt would be success. So that works out to be 0.1024, right? Now we need to calculate probability of x less than 6. Remember, x less than 6 is same as a less than or equal to 5, yeah? So probability of x less than or equal to 5. So this is the rule over here is 1 minus q to the power of 5. So it's going to be 1 minus q, means probability of not succeeding, which is 0.8 to the power of 5. So this works out to be 0.672, correct to 3 significant figures. Yeah. So got to remember, less than, there is nothing less than. Less than 6 means less than or equal to 5, right? Next, for C, two fair 5-sided spinners, each with labels 1, 2, 3, 4, 5, are spun at the same time. If the number obtained are equal, then the score is 0. Otherwise, the score of the higher number minus the lower number is taken. Find the probability that score is greater than 0, given that the score is not equal to 0. So what's happening over here? We need to find the probability that the score is greater than 0. So the score is greater than 0, given that the score is not 2. Alright, so what we're having over here, if I could explain with the help of a diagram, that would be easy. So we're having 1, 2, 3, 4, and 5. Yeah. So they all, two spinners are spun at the same time, and then the numbers, if the numbers are equal, then the score is 0. So like the score would be 0 like for 1, 1, 2, 2, 3, 3, 4, 4, and 5, 5. Otherwise, the score is higher number minus the lower number. So for example, this is going to be 2 minus 1. For 2 and 1, it's going to be 2 minus 1, which is 1. Then 3 minus 1, 2. And then 3. And then 4. And so on. So if I fill this up, so this is going to be 2 minus 1, which is 1, 2, 3, 4. And then 3 minus 2, which is 1, 2, 3. And 3 minus 2, 1. 4 minus 2, 2, 3. 4 minus 3, which is 1, 5 minus 3, which is 2, so 1 and 2, and 5 minus 1, and 5 minus 4, and 5 minus 4 again. Now, probability of the score being greater than 0, intersecting that the score is not 2. So if you cross out the 2's, I'm just going to cross out the 2's. So let's cross out the 2's. Yeah. Now that you have crossed out all the 2's, you need to check how many you're left with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the probability score being greater than 0 and not 2 is 14 out of 25. So we know that that's 14. Then divided by probability of score not equal to 2. Score not equal to 2. So we know that is 14, plus you add the zeros. 15, 16, 17, 18, 19. So that's going to be 19 out of 25. Yeah. Remember, the rule is probability of A given B is probability of A intersection B divided by probability of B. So probability of not 2 is going to come in the denominator. Our calculation simplifies to 14 over 19. Alright, you can leave it as 14 over 19, or you may want to write it as a decimal, but this is acceptable, right? Let's move on to the next question. The two spinners are spun at the same time repeatedly for 9 randomly chosen spins of the two spinner. Find the probability that the score is greater than 2 on at least 3 such occasions. Okay, so now what we're having over here is a binomial, okay, because n is given to you as 9 randomly chosen spins. We need to find the probability that the score is greater than 2 on at least 3 occasions. Yeah, so probability of x is greater than 2. So when we think about binomial distribution, we need to think about what is the value of P and P. P is the probability of success. So we need the score to be greater than 2. So how many numbers are here? You look up into your table. When is the score greater than 2? So 1, 2, 3, 4, 5, 6. So this is 6 out of 25. So the probability of success is 6 out of 25. So I can replace here P as 6 out of 25, yeah, in the binomial distribution. Now we need to calculate probability of x greater than 2. So this is going to be 1 minus probability of 0, 1, 2. So apply the formula for binomial distribution. So it is NCR. You can write it here for you. It's going to be NCR p to the power of r 1 minus p to the power of n minus r. That's the formula of binomial. So this is going to be then the 9 is n for us. So 9C0 p, which is 6 over 25 to the power of 0 times 25 minus 6, which is 19 over 25 to the power of 1, power of 9, plus 9C1, 6 over 25 to the power of 1, 19 over 25 to the power of 8. Then we have 9C2, 6 over 25 to the power of 2, 19 over 25 to the power of 7. That's the last one. And then you calculate all of this. You need to show this step of calculation. There is a mark for it. So it's going to be 0.08459 plus 0.2404 plus 0.3037, and that gives us 0.371. All right, that's the part D. Question number 5. The lengths of western bluebirds are normally distributed with mean of 16.5 and standard deviation of 0.6. A random sample of 150 birds of these birds is selected. How many of these 150 birds would you expect to have a length between 15.4 and 16.8? So we need to calculate the probability of birds having the length between 15.4 and 16.8. This is what our question is. So in this case, we need to apply the rule. Probability of x between a and b is equal to probability of b minus probability of a. This is what we are going to apply to calculate the given probability. So this is going to be then probability of L less than 16.8 minus probability of L less than 15.4. So let us first find the z-score. So the z-score is going to be 16.8 minus the mean, which is 16.5, divided by standard deviation, which is 0.6, minus probability of z-score less than 15.4 minus 16.5 divided by 0.6. Use your calculator to work this out. So this gives me a negative probability of z-score is going to be positive in here, which is going to be 0.5, and this side it is going to be z-score is going to be negative 1.833. Right. So how do we calculate for the negative? It is going to be 1 minus the positive. So 1 minus the positive probability. So use your tables to calculate that. Then this is going to be equal to 0.6915 minus 1 plus 0.9666, which works out to be 0.958. So we need to know what is the expected number expected number of births. So we have total 150 births. So you multiplied the probability by 150. So let me just make some space here. So the expected number would be probability multiplied by 6581 multiplied by 150, which is 98. If somebody writes 99, that is also acceptable. All right. Now, part B. The lengths of eastern bluebirds are normally distributed with mean 18.4 and standard deviation sigma. It is known that 72% of eastern bluebirds have lengths greater than 17.1. We need to work out what is the value of sigma. So we have been given that the probability of x greater than 17.1, or we can say, I'm using x, you could have used L as well. Greater than 17.1 is 0.72. So we need to calculate what is the z-score in this case. It's going to be 17.1 minus the mean divided by standard deviation, which is missing in this case. All that is equal to 0.72. So whenever you have to calculate a probability where x is greater than, and you have a value of percentage which is also greater than 50%, in this case the z-score is going to be negative. So 17.1 minus 18.4 divided by sigma is going to be equal to negative. We need to look at the inverse, phi inverse of 0.72. So look up your table to find what is phi inverse of 0.72. So this is going to be equal to negative 0.583. So if you calculate, then sigma is going to be 2.23. All right. So that's about this question. Part C. A random sample of 120 eastern birds is now chosen. So you have been given now 120 birds. Use an approximation to find the probability. So we have to use an approximation that the probability that fewer than 80 of these 120 bluebirds have length greater than 17.1 centimeter. So in this case, you need to calculate the mean. The mean in this case is going to be n multiplied by p. So n is 120, and the probability of birds having length greater than 17.1 was given in your previous part. That is 72% had length greater than 17.1. So we're going to make use of that. So it's going to be times 0.72. Then the variance is going to be NPQ. That means 120 times 0.72 times 1 minus 0.72. So this works out to be, the mean works out to be 86.4, and the variance is equal to 24.192. We need to now calculate the probability of x less than 80, fewer than 80. It's been given over here in the question. Fewer than 80 had lengths greater than 17.1. So again, standardize it. So it's going to be 80 minus the mean, which is 86.4, divided by standard deviation, which is square root of variance. So square root of 24.192. This works out to be equal to, this score is negative 1.4029, and then you do 1 minus probability of z-score less than the positive, which is going to be again 1.4029. You could round it up to 1.403. That's what I'm going to do, 1.403, and then that works out to be 1 minus 0.9196, which is 0.08 0, 4. All right, that's about this question. Question number 6. In a group of 25 people, there are 6 swimmers, 8 cyclists, and 11 runners. Each person competes in only one of these sports. A team of 7 people is selected from these 25 people to take part in the competition. Find the number of different ways in which the team can be selected if it consists of exactly 1 swimmer, 4 cyclists, and at the most 2 runners. So maximum we can have 2 runners, and we should have exactly 1 swimmer and at least 4 cyclists. So I'm just going to make a small table for you. So we have swimmer, cyclist, and runners. So we need to have exactly 1 swimmer. This cannot change. The number of cyclists could be greater than or equal to 4, and at the most 2 runners means less than or equal to 2, right? So let us try and find what different combinations we have. So we have a team of 7. We need to build a team of 7. So if I go with the first arrangement of 1, 4, and 2, yeah. So we have in total how many swimmers? We have 6 swimmers. From 6 we need to choose 1. So it's going to be 6 choose 1 times. From 8 cyclists we need to choose 4. So it's going to be 8 choose 4 times. From 11 runners we need to choose 2 runners, and this works out to be 23,100. This is the first combination. What are the combinations we can have? The number of swimmers cannot change, so let us say we take 5 cyclists. Yeah, 5 plus 1 is 6 now, and then we have 1 runner. So again 6C1 times 8C5 times 11C1. In this case, the answer is now going to be 3,696. All right. So let's say we have 1 swimmer and we have 6 cyclists and 0 because it's less than or equal to 2. So we can have 0 swimmers, right? So 6C1 times 8C6 times 11C0. This works out to be 168. Then you add them up together to get the total. So the total is going to be equal to 26,964. Part B. For another competition, a team of 9 people consists of 2 swimmers, 3 cyclists, and 4 runners. And the team members stand in a line for a photograph. How many different arrangements are there of 9 people? If the swimmers stand together, the cyclists stand together, and the runners also stand together. All right. So we have one group of swimmers. So we have 2 swimmers. And the other group is for cyclists. We have 3 cyclists. And we have 4 runners. And they all are standing in this way. So 2 swimmers can be arranged in 2 factorial ways, 3 cyclists in 3 factorial ways, 4 runners in 4 factorial ways. Again, these positions can be switched around. So we are going to have then times 3 factorial. This 3 factorial is for the swimmers, cyclists, and the runners switching around. That means you could have the cyclists first, then the swimmers, and then the runners. Any other combination also is possible, and therefore when we write 3 factorial, it takes care of everything. So work this out. This gives us 1,728, right? And part C now. How many different arrangements are there of 9 people if none of the cyclists stand next to each other? So here they are saying that none of the cyclists stand next to each other. So none of the cyclists stand next to each other. We have 3 cyclists, and then we have 2 swimmers, and we have 4 runners. All right. So when there is a case of 3 people not standing together, you cannot use the method of all the combinations minus the C's together. You cannot use this one because it doesn't take into account the possibility that 2 cyclists are together. Yeah, so this method doesn't work when we have 3 cyclists or anything that has 3. So what should we do then? We should use the method of gaps. So if the 3 cyclists are gone, then we are left with 2 swimmers and 4 runners. So the cyclist can go in anywhere in the gaps over here, right? So let us see how many we have over here. We have 2 swimmers and 4 runners. So that is 4 plus 2, that is going to be 6. So they can be arranged in 6 factorial ways. And then how many gaps do we have? 1, 2, 3, 4, 5, 6, 7. So 7 gaps. So it's going to be 7p3. It's 3 because there are 3 cyclists that we need to arrange. So 6 factorial times 7p3 is going to be your answer, which works out to be 151,200. All right. So that's about this paper. If you haven't subscribed to my channel yet, make sure that you subscribe to my channel, and see you in the next tutorial. Thank you for watching.